Question number 41. The temperature coefficient of resistance for a thermistor is options: low and negative, low and positive, high and negative, high and positive. This question is a concept based question and simple and straightforward question. Let us see what is a thermistor and how its temperature of coefficient varies. Fine. First of all, we'll see what is a thermistor. Thermistor, the name itself indicates thermally sensitive resistor. Thermistor is nothing but thermistor is also a resistor whose resistance is dependent on temperature. Means the resistance of that device varies with temperature. It can either increase or it can either decrease. So what thermistor is, the first term indicates THER, therm is nothing but thermally sensitive resistor. Istor means resistor. So in short, what is thermistor is? Thermistor is nothing but thermally sensitive resistor. Thermistor is a thermally sensitive resistor. Now let us see what thermistor will do and what are the kinds of thermistors. Fine. Thermistors are generally of two opposite fundamental phenomena. That is, a thermistor can be of NTC and a thermistor can be of PTC. Means NTC indicates negatively temperature coefficient it has, PTC means positive temperature coefficient it has. What is a NTC thermistor? See, these two types of materials are available. So thermistors can be of NTC thermistor or PTC thermistor. First one is NTC thermistor. In NTC thermistor, the resistance decreases as temperature rises. It's like resistance is inversely proportional to temperature in case of NTC thermistors. In case of PTC thermistors, resistance increases as the temperature increases. It is directly proportional to temperature. Okay, so as the temperature increases, the resistance gets increased. In case of PTC thermistors, if the temperature increases, resistance decreases in case of NTC thermistors. These are the two basic operations of thermistors. Now typically among this you may get which one will use typically. Typically the first one is initially discovered and this is largely available in the market, and we will use the first one. NTC thermistor is widely used. Okay, NTC type of thermistor is widely used. Please remember, NTC is widely used. Fine. Now let us see a few more details of thermistor, then we'll go back to the question. Then thermistors, see, there is also known as other device called RTD. Then what is this RTD? You may ask a question like, what is an RTD? RTD is nothing but resistant temperature detector. Okay, so this is also a resistor which detects the temperatures. So how you can raise a question like, what is the difference between a thermistor and a RTD? So it is very simple. RTDs are generally made up of pure metals, whereas thermistors are made up of ceramic or polymers. You can read these points, you will come to know. Also, RTDs are used over large temperatures, where thermistors are used for small temperature, and these thermistors will have lot of precision. So thermistors will have greater precision. Means even if there is a small change in temperature, the resistance varies. Either it will decrease or increase. So even for fine temperature 0.01 degrees Celsius, if there is an increase in temperature also, the resistance will either increase or decrease. It will be deflected directly. So for smallest changes in the temperatures also, thermistors are useful, and thermistors resistance will change. So hence the reason we'll use thermistors in a high amount. Especially NTC thermistors are highly used and they have lot of precision. So let us see the equations related to thermistor. So you might have already known the equation related to resistance and temperature. Resistance at any temperature is given by resistance at some temperature, initial resistance R0 into 1 plus alpha delta T. So I have simplified this. I have brought R0 to the left side and I simplified, and I found an expression for alpha. You can go through the calculation. It is not a complex thing, it is very simple. So from the first equation I got the second equation. So alpha indicates coefficient of temperature coefficient of resistance. Alpha indicates temperature coefficient of resistance. Okay, so equation for alpha, try to memorize: 1 by R0 delta R by delta T. R0 is the initial resistance. Okay, so what I want to say is, if alpha is positive, then it indicates PTC. It's simple, right? Because if alpha is positive means this is a constant, this by this temperature is also increased, means this is greater than 0, right? So if alpha is positive means delta R is positive. Means what I mean to say is, if alpha is positive, everything is constant except delta R directly. Delta R is also positive because R naught is a constant and this always it's a positive quantity. So this is a greater than 0, means R2 minus R1 is greater than 0. So R2 is greater than R1, means if alpha is positive, then resistance is increased, which indicates PTC. I already discussed. If alpha is less than 0, then delta R is less than 0, then R2 minus R1 is less than 0, then R2 is less than R1, means resistance is decreased, it indicates NTC. So in this way you can conclude based on the values of alpha. If alpha is positive, it indicates PTC. If alpha is negative, it indicates NTC. If alpha is 0, then it indicates, see, alpha is 0, what does it indicates? Delta R is 0, means R2 minus R1 is 0, means R2 is same as R1, means there is no change in the resistance. So alpha is 0 means resistance is independent of temperature. Even though if you increase the temperature, the resistance remains same. So in this way, based on the values of alpha, you can conclude the value of whether the resistance is increased or decreased. Now let us come back to our question. The temperature coefficient of resistance, which is nothing but alpha, of a thermistor, for a thermistor, is low negative, high positive, whatever he is asking. I already told there are two kinds, PTC and NTC. So it can be, for NTC it is positive, for PTC it is negative. I already told one more point also, this is typically used, widely used. Okay, so definitely alpha should be less than 0, so it should be negative. So these two options cannot be, these are positive, it can be negative and negative. Also, as I was discussing, I mentioned one more point. See, I was mentioning 2 points. It is like we'll use NTC widely, and also it has greater precision. So it has greater precision, I was telling you. So NTC and it has greater precision, right? So what I mean to say is, it is negative, you agreed, fine. Greater precision means alpha should be high, it should be highly sensitive. Alpha is high means it has high sensitive nature. So in this case, that's why I'll choose option C as the right choice, not option A, because they are highly sensitive and it will provide a great precision. Hence alpha should be large negative value. If it is large negative, then it will predict large changes in the resistance. So in this way you will eliminate option A, then you will choose option C. See, everybody will make a 50-50 of A and C, and they'll eliminate B and D. Between A and C you should choose properly, fine. So in this way we'll conclude this question. Okay, if you have any doubts, post them in the comment box. Subscribe the channel for getting more updates. Thank you.